La, 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 la. After this match, I'm going to do that little math mini lesson here. I'll sit out one game.
Yeah, she got me. God dang it! Well, not her, but her team.
How many people are here?
There's three more alive.
Alright.
I only got one down, and I didn't kill her. She was just.
They went in here, Kenneth.
Right there they are.
Are they in or out? Blow up, boys! Blow up! Not one. Get out of here. Not two. Grenades are brutal, boy. I think they're all gone. You got it, dear. What the wife wants, the wife gets. Right here, in front of us. Knocked one.
Oh no.
Oh, he's swinging away.
Let me get some help for a second.
Knocked him. Triforce player. Ooh, I think he had a crown. No, that's webs.
I can't believe we let the foundation show up and we have the crown.
Is that a blue MK? Nice. Oh, oh, there's three of them in there. I got one. I'm pushing. I'm pushing. Boom, baby! Boom! What's my day? Baby, I'm gonna sit one out too. All these darn screens. Alright, so this is I got goals to incorporate math. I've had them go a long time to incorporate math in my streams. So that in mind. The first lesson that I'm going to cover in my trig classes coming up this Monday is just the introduction to Radian measure. So anytime, person that isn't in a trig class or isn't specifically talking trig talks about angles, usually they use degree measurements. But in trigonometry and classes that based in trig, you need to really know what a radian measurement and what radians are. So if you hear, let's say in some kind of application, there's an angle of 2 pi over 3 radians, right? Do you know about how many degrees that is, or that an obtuse angle? Is that an acute angle? What kind of angle is that? And what does that 2 pi over 3 mean? We know the circumference formula for a circle is pi r, right? So this is going to kind of show where that 2 pi r comes from in terms of circumference. All right, so first thing I want to do is talk about just angles in general, the standard form position of an angle. So if I were to sketch some angles, let's first sketch coordinate plane. Here's your coordinate plane. You got your x-axis, y-axis. All right, so in terms of quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. In each quadrant, we know if we have a point that lies in a particular quadrant in the coordinate plane, we know the sign of X and Y coordinates. So any coordinate in quadrant 1 positive X, positive Y value. As you go counterclockwise in quadrant 2, if you plot a point in quadrant 2, say somewhere here, right, you're going left, the x-axis. Right here is the origin. It's 0, 0. You go left, then you're talking about negative numbers. Left, or the horizontal axis, is x value. So coordinate in quadrant 2 would have a negative x value and a positive y value. Coordinate in quadrant 3 would have both negatives. Coordinate in quadrant 4 would be a positive x. That's a short review. So let's talk about angles. All right, so angle in what we call standard position, something like this. All right, standard position means its initial side is along the positive x-axis. Its terminal side, where it terminates, is what's the measurement in which this is opening up. All right, we're going to open up counterclockwise. So if I say let's have an angle that is 120 degrees, well, I know this is 0 degrees. Axes are perpendicular, so this would be 90 degrees. 80 degrees, 70 degrees, and in full rotation, 360 degrees. All right, so if I want to plot or sketch an angle in standard position that is about 120 degrees, well, I would sketch the initial side like I have here, then I would open up counterclockwise about 120, like this. I would say that is opening up this way. That's what that little arrow indicates. 120 degrees. So that is an angle in standard. What's neat about this, though, is let's say we want to sketch angles that are negative, or we want to sketch angles that are greater than 360 degrees. We can continue to go about this circle right here in increments of 90 degrees and say, okay, well, if I have 0 here, 90 here, 180, 270, 360, well, I can continue. Not only would this positive y direction indicate a 90-degree angle, it will also indicate 450, 360 plus 90. If I can continue, this is 450, 40, so 630, 20. So, if you wanted to sketch an angle that has a negative measurement, then you will take this 0 degrees and you would just go clockwise to indicate the negative direction. So not only is this 270, 630, you could also label that as being negative 90. And so in a clockwise direction. So counterclockwise, it's positive measurements. Clockwise indicate negative. What is radian measurement? So I'm gonna give a definition, sketch a circle, and put the idea of a angle in standard position alongside the idea of a radian measurement, and give you a picture of what a radian is. So I'll draw a circle first. Not a perfect circle, but it's all right. All right, in a circle, we have the center here. All right, we know the radius of a circle is the distance from the center of that circle to any point outside of that circle, say there. So I can label this R. All right, if I have a radius there and say a radius here, radii are equivalent. So a radius anywhere about the circle equal to any other radius about the circle. So if it doesn't matter where the radius is, it has the same measurement anywhere in the circle. So I have two radii here. Of course, they're equivalent. I'm gonna call this angle that these two radii create central angle. I'm gonna label it theta. And this arc right here, the arc that is intercepted by those two radii, label that S. All right, so that picture in mind, 1 radian is the measure of the central angle of a circle that intercepts an arc equal to the radius, to the length of the radius. See if my boom. All right, so in other words, theta in radians, all right, theta is in radians, but in rads, equal to S over R. So in other words, if S and R are the same measure, so if I come up here and I say this S is equal to R, if S is equal to R, then the central angle where that happens is 1 radian, right? When your arc that is intercepted by these two radii is equivalent to the radius, same measurement, then the central angle is radian. Right. Pretty cool. So the diameter of the circle is a chord that goes through the center of that circle. All right. So color. So that that green radius is R. The orange one R. Right. So the arc that is intercepted here this. Right. So what is the central angle? That central angle of, say, semicircle, right? Diameter splits a circle in half. Therefore, you have two semicircles above, below. So we got a semicircle above diameter, semicircle below the diameter. All right. There are 360 degrees circle. Right? So if I were to put this circle on a coordinate plane, ew. Better? All right. And label the diameter, which is going to be the x-axis here. So, all right, the diameter is a straight angle. So we know straight angles are 180 degrees, which goes back to sketching angles earlier. The initial side, this straight angle would be here. terminal side here. All right, so this angle in terms of degrees is 180 degrees. That angle is 180 degrees. All right, which makes sense because in a circle, if you have 180 degrees here, and then this semicircle, another 180 degrees, then you add those together, you get a full circle, it's 360. So there's 360 degrees in a circle. All right. What is that in radians? Well, let's talk about the circumference of a circle. Circumference of a circle is circumference is equal to 2 pi r or pi d, depending on how you're taught. Pi d. D being the diameter, and we know the diameters. So 2r and d are equivalent. All right, radius is r, d is diameter. So 2 radii, that equals. So if we have a circle that has a radius 1, if radius is equal to 1, then circumference is 2 pi. All right, circumference is the distance around a circle. So if I have a circle that has a radius 1, then the distance around that entire circle is 2 pi units. Right? Pi is approximately 4. So if I have a semicircle, what is the length of a semicircle? The arc of a semicircle. So the distance around, if r is equal to 1 here, distance around this circle be 2 pi. The distance around the semicircle would be half that. All right, so the distance around the semicircle would be pi. Why is that important? Well, we want to eventually have some sort of relationship between degree measurements and radian measurements, and we just arrived at that relationship. So if you're talking about a full circle has 360 degrees. Right? There's 360 degrees in a full circle. Okay. The distance around a full circle, if the radius is 1, is 2 pi, 2 pi units. So 360, the distance around a full circle, 2 pi units, same thing, right? So the distance around a full circle, circumference, if the radius is 1 pi units, you also travel 360 degrees to get there. So if you travel half that, 80 degrees, then the arc is half of 2 pi. In other words, 180 degrees is equal to pi radians. 180 degrees is equal to pi radians. So that is a very, very, very important conversion factor. So now if we go back to beginning, where we sketched a 120-degree angle, initial side, 120 degrees. If this is 90, 120 is about right here. I can convert that 120 degrees radian measurement using that conversion factor. So important conversion factor is 180 degrees equal to pi radians. So if I want to convert 120 degrees to radians, what I would do is take 120 degrees. I can represent that as a fraction by just writing it over 1 is equal to, when you convert things, excuse me, not equal to, times. All right, when you want to convert things, say you want to convert 15 ounces into cups, right? How many cups is 15 ounces, right? Or how many pints? You have 7 cups. How many pints is that? Convert. Anytime you use conversion factors, you're just multiplying fractions, right? So if I want to convert 120 degrees into radians, I want to multiply 100 degrees over 1 by the conversion factor such that the degree unit cancels out. I don't want degrees. I want to convert 120 degrees radians. So I want to multiply by the conversion factor fraction form such that the degree unit cancels out. My degree unit is at the top of my fraction of 1 of my conversion factor, which is this, my conversion factor. Write it in terms of fraction. 180 degrees equals pi radians. Those two things are equivalent. So if you divide one by the other, you get 1, right? If I multiply anything by 1, I get the exact same thing. But I'm not multiplying by the number 1, I'm multiplying by a conversion factor, which is equivalent to 1. I just need to make sure I multiply the correct way in terms of either pi over 180 or 180 over pi. In this case, since my degree unit is top of what I'm converting, I need my degree unit conversion factor to be in my denominator. So 180 degrees is in my denominator. Pi radians is in my numerator. That green fraction is equivalent to 1. Therefore, I'm multiplying 120 degrees by 1. It's just a weird way of writing 1. So the degree unit cancels. So now I have radians. So I have 120 pi. I don't want to approximate pi. I want to keep it exact. So pi is an irrational number. So only way to keep this as an exact angle measurement is to keep the pi in angle measurement. So do not approximate. 3.14, we don't want to use that. Will be rounding. That will be approximating. We want to keep things in exact terms. So we're just going to multiply our fraction. So 120 pi over 180. Of course, that's radians. And then reduce. So zeros, well, both of those two. We don't need to worry about the pi unit. Pi is just going to stay there. All right, so we're going to reduce the one, both divisible by 10. So I can basically reduce both by 10. 120 divided by 10 is 12. 80 divided by 10, 18. So that's just the easy way. If you have numbers that both end in 0, you can divide by 10. That's basically what I just did there. And it makes it a little easier to reduce 12 over 18. GCF between 12 and 18 is 6. Divide them both by 6. Reduce both of these numbers by 6. You'll get 2 pi over 3, which is that measurement that I'm talking about. So 2 pi over 3 radians is equal to 120 degrees. So if you have an angle measurement, radians, that is less than 180 degrees, excuse me, I'm sorry, if you have an angle measurement that's less than 180 degrees radians, that angle will be less than pi, less than 1, right? So 120 degrees here is obviously less than 180, thirds of 1. Therefore, radian measurement is 2/3 pi, since pi 180 equivalent. That's basically all I wanted to do today. Nice little go back and look at my VOD, video on demand, see how I can things up. But that was a little bit of fun. I'm going to finish off by writing a couple of questions up here. Convert to radians. Let's see here. 545 degrees. Negative 80 degrees. And convert degrees. So we can do it in the other direction too. If we ever have an angle that is given to us in radians, we can convert that to degrees using the same conversion factor but flipped. So if I want to convert, let's do 6 pi over 5. I can figure out how many degrees is this equivalent to by multiplying by 180 over pi, and therefore the pi unit will. But I can look at it and say, okay, well, 6 pi over 5. 6 over 5 is just a little more than 1, right? 6 over 5 is 1.2. So I know in degrees, the angle will be slightly bigger than 180 degrees. I convert that, I can look at it, I can look at the ratio of pi that my angle is, and kind of in my head think about, okay, so if 6 over 5 is my coefficient of pi, 6 over 5 is just a little bigger than 1, therefore my angle in degrees should be a little bigger than 180 degrees. It's 180 equal to pi in terms of conversion factor. So little tricks like that, I know when I was a student, little tricks like that, I would look at things and make associations, create these little tricks that I could memorize, or I could, maybe not memorize, but I could troubleshoot if I've made a small mistake, because it's very easy to make mistakes in anything. Really in math, very easy to make mistakes. And negative angles can be negative. Negative angles, or to sketch negative angles, the initial side would still be the positive x-axis, but in terms of sketching it, you can sketch it by just sketching it in clockwise direction. So there is such thing as negative angles. In terms of the coordinate plane, this is 0 degrees, 0 radians. If I go in clockwise direction, this would be negative 90, negative 180, 70, negative 3. Negative pi over 4, I will kind of first convert that. I will get a negative degree measurement, and then I can figure out where that will be in my coordinate plane. And this is going to eventually lead us to something sine tangent, where we could say, okay, what is the sine value of negative pi over 4? I can visualize where that is, and I know what sine is in terms of exact values, then I can easily find that value without calculator, just by visualizing where negative pi over 4 is, or whatever angle you're dealing with. Now, obviously, you can't do that all angles, only specific angles that you can find what we like to call exact values, sine, cosine, tangent. Only, well, we'll get to that later, but you do eventually need a calculator, because you can't calculate all that in your head. But that's my little introduction. I hope it was fun. Thanks, two grown men. There we go. What's my name? Man, it's tough. Here you go, Wise. Here's what we've been doing with some trig. What you think about that? Part between degrees and radian measurements. Talk about what a radian was. Pretty fun. Then we did a couple of examples. Ended up getting here. My head hurts already. Oh, it ain't that bad. But I'm going to clip the little math section that I did and put it on my YouTube, which I do have 11 subscribers. Yes! Building that up, right?